Today we'll look at how to find the overall maximum function from a set of xy functions. Here I have two functions, but you could have many more. And I'll plot them, and what we'll see is that the data is not synchronized. And what I mean by that is that for any given x value, there's only one y in common with that x. So the data is staggered. So what we need to do first, before we can find the maximum, is we need to synchronize these functions. Now to synchronize it, we need to select an increment. The finer the increment, the more accurate the result will be when we finally find the maximum. Here I'm going to leave it fairly coarse for the data so that we can see the effect of leaving it coarse. We can also select the interpolation method depending on what type of function it is, and these are linear functions, so we'll leave it linear. Now that the data is synchronized, if we take a look at the data and probe it, you'll see that for any given x, there are exactly two y values, one for each function. Here you can see also at the intersection, we don't quite capture that, but if we had refined that increment, we would get much closer. So now we're ready to find the maximum of these two synchronized functions. So we'll find the maximum amplitude and we'll append it. Then we'll go ahead and plot it. And here you can see the overall maximum of those two functions. You can also overlay the initial functions as well. And here you can see what happens at the intersection because we didn't have a fine enough synchronized increment.